Hi everybody. I thought today I would quickly take you through the software aspects, and the first up would be the Arduino software. And it's fairly simple, it's quick and easy really, not a lot in here, but I'll take you through the various aspects of CremaBot itself. So, as you can see right on the top, I've included the keypad.h include file. That makes it really easy to speak to the 2-row by 3-column matrix, keyboard matrix. So it doesn't even have to be a standard matrix. It's keyboard. The keypad at H works with any kind of matrix and keyboard setup. So going from the top, we'll get the pin declaration. So first of all, 74595 chip. You need a latch pin, a clock pin, and a data pin for that. For those of you that want to see how this matches up with the actual wiring diagram, how do you connect that in? You can see that in a separate video that I did on the schematic and board creation. I'll link that in below. The next step is the keyboard interface. So as I said, we have 2 columns and 3 rows, and these are the pins that I'll be using for those. So pin 12, pin 11, pin 10, 9, and 8. There's the motor interface, which is at this stage not implemented in the current version. Well, not implemented in the installed machine at my client, but the circuit board, and as you can see, the software is ready to go. There's our step pin, our enable pin, enabling the motor driver. There is the step pin and the direction pin. Then our output data constant. So these are the values that I sent out to the matrix. We'll get to in a bit. For the machine to perform the various actions, right? So if I want to rinse, I need to send 14 out to the 595, which will then forward that on to the matrix. Again, 22, 26. So if you look at these bit values, here is a quick spreadsheet that I put together just to show the how I make up those numbers. So there's rinse 14, and there's the binary representation of it. Espresso is a similar thing. So how that looks, I've just transferred those same values over there for quick and easy reference. Then we go through and we do the keyboard variables. So there's 3 rows, 2 columns. Here we do the setup, or we create the array that we'll pass into the keyboard setup later. There you can see the same characters: rinse, coffee, espresso, 2 coffees, 2 espressos, and steam. On this one, we build the arrays, the full arrays for the keypad, and here we actually do the keypad setup. Right, little other variable. So then we get into the setup routine. Setup, we go do all the pin setups for the various instances, and initialize the serial port. And you'll see the first time you plug CremaBot in, it actually displays or sends this over the serial port, so you can always see what version you've got, what hardware version you've got, etc. Got a debounce timer set up in there for the keyboard, and then also I've just flashed the LED 5 times to indicate during debug mode that everything's set up and good to go. Right, then we got some global variables, just key and byte, just a little counter in there, and then we're into the loop, and this is a piece of code that obviously executes over and over and over. So the first thing I do is I read the keypad. Okay, then I read the serial line coming in from the machine, from the PC or the server. So I only do that though if no one has pressed a key, because obviously the local keyboard always takes precedent because there's someone standing in front of the machine. And I read that value into the same variable if available. So if the variable is null there, then I read from the serial if there's anything in there. So then if someone's either pressed a key or sent a serial command, I execute that key. So in the case of a R or a rinse being pressed, I execute this method called press, and I pass in rinse or whatever button is pressed, and we go through that method in a moment. And when we're done doing all of that, I simply send that same key back to the PC via serial. So if you send a command, it'll get echoed back, but when you press a button, it'll end up at the PC as well. And that is obviously to align the animations, and you can do all kinds of fun things with that, so that when you press the button on the machine and you're just staring at the website, you'll still realize on the app that someone has actually pressed the button, because the animations will execute. So here's our press method. All press does is take that number and pass it into the output data method, which is below, and then waits 50 milliseconds. Output data, so what I do here, this is the bit that actually sends data out over the, or to the 74HC595 in my case. And what I do is I set the latch pin low. You shift out the data, so this is a standard method that's available. You have to specify the data pin, the clock pin, which we all set up above. You specify whether you want most significant bit first or least significant bit first, depending on what you need. And then the number to display, which is simply the value that I passed in. And once you've done clocking all the data out, you set the latch pin back up to high, which indicates to the 74595 that it can send this data to its output. I'll wait a second, and then I just clear the 595. So exactly the same process. Latch pin low, clock out 0 in this case. So it sets all the pins to low, and then turn the latch pin high again, indicating that it can send it out. And here's my little flash routine. What this does, it's just a little thing that you can decide how many times you want to flash the LED, and it sets it high, waits 50 milliseconds, sets it low, and waits 50 milliseconds. And that's all there is to it. It's quick and easy. I said it was simple. And I hope you enjoyed this video. Let me know if you guys have any good comments or criticisms. I'm by no means an Arduino expert, so if you spot anything that I could have done better or could have done differently, I'd appreciate your feedback. Leave it in the YouTube comments, and I'd really like your feedback on that. If you like this video, give it a thumbs up. See you all later. Cheers.